The human body manufactures the electricity required to control its every vital function. We are powered by an internal biological grid. A heartbeat or a simple muscle flex relies entirely on this constant flow of electrical data. External electricity is often categorized as a destructive force, capable of causing severe tissue damage. Yet, applied with precision, controlled electrical stimulation is a primary tool for managing chronic pain. Early researchers developed methods to capture and store electrical charge long before the biological mechanics of the body were understood. The Leyden jar was one of the first devices to demonstrate this capacity. The jar's ability to hold potential energy across an insulating barrier mimics the fundamental mechanism used by human cells to store their own electrical potential. This raises a question of coordination. How does an external current successfully interact with this system to suppress a natural pain signal? By manipulating electrochemical gradients, we can physically interrupt pain pathways and intervene in the body's response to injury. Electricity is the foundational programming language of the nervous system. Every cell maintains a negative internal charge relative to the environment outside its membrane. This charge is the result of a specific distribution of ions, primarily sodium and potassium. Sodium remains concentrated outside the cell, while potassium stays concentrated inside. The cell uses a sodium-potassium pump to actively maintain this chemical imbalance. This state of stored potential energy is called the resting membrane potential. This negative baseline remains stable until a stimulus, such as the heat from a hot stove, triggers the cell to fire. During depolarization, voltage-gated channels snap open and allow a flood of sodium to rush in, instantly flipping the internal charge to positive. To reset the system, the cell ejects potassium, restoring its negative baseline in a phase known as repolarization. This sequential wave of shifting voltage is the action potential. This single unit of communication is the only way the nervous system transmits information. Without this movement of ions, the brain cannot perceive a stimulus. While natural action potentials originate from heat or pressure, they can also be induced artificially. External pulse therapy involves applying a localized electric current to the skin directly above a target nerve. The external voltage forces the underlying voltage-gated channels to open, mimicking the effect of a biological trigger. In both cases, the resulting sodium influx and the cascading wave of electrical propagation are identical. The nerve fires a legitimate biological action potential, indistinguishable from one triggered by natural injury. The artificial signal, however, is commanded by a device, allowing us to specify the exact frequency and amplitude of the message. External neuromodulation allows us to speak the nervous system's native language to issue new commands to the body. Transcutaneous electrical nerve stimulation, or TENS, focuses these commands on the sensory nerves. The therapy utilizes rapid, mild electrical pulses delivered through electrodes. A natural pain signal travels slowly along its nerve pathway toward the brain. The artificial action potentials from a TENS unit travel significantly faster, racing ahead of the slow pain signals. According to the gate control theory, these rapid artificial signals reach the spinal cord first. They occupy the synaptic junctions, forming a blockade that prevents the pain signals from proceeding. The pain signals are physically interrupted at the spinal junction. For the patient, this interruption means the brain no longer registers the chronic pain coming from the injury site. If the signal is blocked at the gate, the perception of pain cannot exist. Electrical muscle stimulation, or EMS, targets the motor nerves instead of sensory ones. EMS uses a higher amplitude current to bypass sensory blocks and trigger motor pathways directly. This stimulation forces the muscle fibers to undergo rhythmic, involuntary contractions. These contractions cause significant localized vasodilation, expanding the nearby blood vessels. The increased blood flow flushes out inflammation and delivers oxygen and nutrients to repair chronic injuries. TENS creates an informational blockade to stop pain, while EMS acts as a mechanical pump to stimulate physical repair. These cellular principles are now integrated into clinical hardware used for home therapy. Modern devices utilize external voltage to either block sensory pain or force motor tissue regeneration. Dual-channel systems allow a user to target multiple nerve pathways or muscle groups simultaneously, combining pain management with active recovery. Decades of electrophysiology research have been condensed into accessible technology for daily use. The human body is a biological circuit, and we now have the interface required to override its programming. We no longer have to passively accept the body's signals of pain.